Hello everyone. So how are you? I hope you are doing the lectures well and seeing the lectures well and studying. See, this chapter is very easy, and if you know alkyl aldehyde ketone carboxylic acid, alcohol phenol ether and bit haloalkane haloarine, so you can see and you can do this clearly. This chapter is very easy. Okay, so today we are going to see a very important topic, that is carbamine reaction. Carbamine reaction. Now what is this? See, this is a one type of a chemical reaction of amines, and this is one type, this also known as a isocyanate test. Isocyanide test. Okay, so this carbamine reaction is also used to test the isocyanate. Now what do you mean by isocyanate, beta? So isocyanide is this R and triple bond C, in which here it is minus and here it is plus. Sorry, on nitrogen is plus and carbon is minus. How? We will see in the reaction. Just now you remember, this is nothing but your isocyanide R and triple bond C, in which nitrogen will give plus and C will have a minus. Clear? This also sometimes in question they are asking, in MCQ asking which of the following is a correct formula for isocyanide. R is joined with N, triple bond C, on N plus will come and C minus will come. When I will do the mechanism, you will understand. Instead of R, it will come AR also, N triple bond C, here plus and here minus. Now clear this part, but there is one problem here. The problem is what, you know, this test is only used for 1 degree amine. So this test will give the positive results for 1 degree amine. Means isocyanate test is there, no beta? So isocyanate test is only used for 1 degree amine. This test is not used for 2 degree or 3 degree amine. This is only used for 1 degree amine only. These 2 points, if you remember, story over. So carbamine test, so another name of a carbamine test is also known as a isocyanate test. Isocyanate means R and triple bond C. On this end positive charge will come and C minus charge will come, or instead of R you can add on here AR N plus C minus, and now here means either ring will come or alkyl chain will come. Okay, but the test is, this test will give only positive result for 1 degree amine. Means carbamine test is only used for 1 degree amine. Carbamine reaction will only use for 1 degree amine. Very important for MCQ. So carbamine reaction or isocyanate test is only used for 1 degree amine. How it is seen? See, example, we will see this here. Example, I am taking here RNH2, and this RNH2, first it is reacted with chloroform, that is CHCl3, in the presence of one basic medium. So it will generate and bit heating is required. It will generate isocyanide R N triple bond C. Here plus will come, here minus will come. This you should remember. This will ask. So R N triple bond C, plus will come, C will come. This K will form KCl plus H2O. This will be generated. So this is your nothing but carbamine test. If you take 1 degree amine and when you react with chloroform in the presence of a basic medium, it will generate isocyanide. But instead of 1 degree amine, if you take here 2 degree or 3 degree, result will not come. Means I will write down here no reaction. So if this is 1 degree amine, yes, reaction will come. So I can write down here amine and carbamine test, or I can write down isocyanide test. So I write down here 1 degree amine, yes, result will come. 2 degree, result will not come. 3 degree, result will not come. So isocyanate test or carbamine test is only for 1 degree, not for 2 degree or for 3 degree. So what will happen if you take 1 degree, and in carbamine test what we are doing, you can see, I will share the link also for carbamine test. You can see in my description if link is available. So see, 1 degree amine you take, and when you react with chloroform, this is a chloroform in the basic medium KOH, you can take here NOH also. So here isocyanide will be generated only for 1 degree amine, not for 2 degree or for 3 degree. Now you have to see the mechanism, and how we'll come to know whether the reaction has occurred or not. whether the reaction will occur or not, it will come through the false smell, because this is a false smelling compound. False smelling means you will feel to puke, you will feel to vomit, that type of a smell will come. So as soon as you, suppose I am giving you, when you come to the laboratory, I will give you two test tube I will give, and I will tell you, in this 2 test tube I don't know which is 1 degree and which is 2 degree amine. How will you distinguish? I want to distinguish 1 degree and 2 degree. So what you will do? Simply you will perform isocyanate test. Suppose test tube A, you take test tube A, and when you perform the test, you do not get false smelling. But when you perform the isocyanate test with test tube B and you got false smelling, then you understand, the test tube B is 1 degree, then guarantee test tube B is 2 degree. The reason is what? Test tube B is a 2 degree, means in test tube B is 1 degree and test tube A is 2 degree. Means test tube A has not given any kind of a smell, but test tube B has given the false smelling, and 1 degree amine will react with isocyanate test and give the false smelling. So test tube B is having the false smelling on reaction, means test tube B is having 1 degree amine, and test tube B there is no false smelling, means he has not done the reaction, so test tube A will have a 1 degree amine. So always it will generate a false smelling compound which is known as a isocyanide, or that's why it is also known as a isocyanate test. So clear? Now we will see the mechanism of isocyanide test. We will see the mechanism. See the mechanism. See, in the first step, chloroform will come. Chloroform is CHCl3. So here Cl, here Cl, here Cl, here H. This will react with KOH. And see here, if it is reacting with KOH, so this is K plus, this is OH minus, and this is an acidic hydrogen. Because carbon is associated with more negative element chlorine, so this bond is stronger, this bond becomes weak. When this bond becomes weak, it will release as OH, H plus. So this OH minus and here H plus, means H will donate its whole lone pair here and release as H2O. As H2O. So see beta, here carbon will take its lone pair of hydrogen, here Cl, here Cl, here Cl. Yes or no? This is the first step of the reaction. Now understood? Second step. This chlorine is a good leaving group, as you know. So it can easily release as Cl minus. So this chlorine will release as Cl minus, and there is a presence of K plus. So there is a presence of K plus, that's why only this Cl minus is releasing. So there will be generation of KCl, and this compound will be generated. Here Cl, and here one lone pair. So this itself we call as a dichlorocarbene. Understand, you know, this dichlorocarbene. This we have not listened first time. Previously also somewhere I have done in alcohol phenol ether. Now see this. See the outermost orbit here, 1, 2, 3, 4, 5, 6. So there is a need of electron here, means this will act as now electrophile. And we have a nucleophile in the reaction. See, I have used chloroform, I have used KOH, but I have not used the amine. So I will take now here RNH2. It is having a lone pair. So it can donate the lone pair, means it will act as a nucleophile. And it can act as, it can accept the lone pair, means it will act as an electrophile. So here Cl, here Cl. So this lone pair will donate it to this carbon. Now what will happen here? R, here N, here H, here H. This nitrogen has given its lone pair to this carbon, creates positive charge. This carbon has taken the electron, creates negative charge. Here there will be Cl, here there will be Cl. Clear this part? Now, what will happen? Now see here. So up to here we have reached. Okay, great. Now, what will happen? Now, one more part of KOH will come. What will happen? See here. This nitrogen is having the positive charge. This nitrogen is, see now this will form here K plus and OH minus. So this nitrogen is having the positive charge. Nitrogen being an electronegative element cannot stay in the positive charge. So what will happen? This hydrogen will give its electron and shift this bond here. So nitrogen is making a new bond with this carbon. Or I can say carbon is making a new bond with this nitrogen by releasing H plus. So when carbon is making a new bond with nitrogen, so he has to break the old bond. So Cl will be released as Cl minus. Cl will be released as Cl minus. So now what will happen? See here. The reaction will occur in this way. This H is removed as H plus to form H2O, and this Cl is removed as Cl minus to form KCl. So what answer will come? Answer will come here R, it will come here N, it will come here H, plus remains as it is. Double bond, yes or no? Because bond is shifted here, no? Double bond, C minus as it is, and Cl is removed as Cl, so it will form here Cl. Because Cl minus has gone, no, now. Cl minus has gone. Clear? Done, beta? This is the first step. Second step, again KOH will come. Again KOH will come here. See this reaction now. So this KOH will again form K plus and OH minus. Again nitrogen, there is a plus charge on it. So it is an electronegative element, should be negative charge. So now this hydrogen will release as H plus and shift here, bond. So carbon is again making a new bond with this nitrogen. So to make a new bond with nitrogen, he has to break the old bond. So Cl will be released as Cl minus, so here K plus, it will form KCl, and here H is removed as H plus, it will react with OH minus to form H2O. So what will be generated? See here. So R, N, this bond is shifted here. So previously double bond was there, now triple bond, C and Cl has gone. So nitrogen will have a plus charge and carbon will have a minus charge. That's why in the initial classes I told you, previous topic I told you, the nitrogen will have a plus charge and Cl will be having the minus charge. So this is nothing but your isocyanide, RNC, plus charge, and here minus charge. Clear this part? This is your isocyanide. Write down this. Someone will come here, someone will go from here. Okay. This is known as your isocyanide. 1 degree reaction will show. When you go with the 2 degree, I am not doing the mechanism, not required, it will not show. Clear? It will show only up to here. Further it cannot topic. See, I am completing whole reaction. To form an isocyanide, two time reaction we are doing. This is the first reaction. This is the second reaction. But if it was here 2 degree amine, here only we would have stopped. When we have stopped here itself, here there is not a generation of isocyanate. Here there is a generation of isocyanate. So I cannot go with 2 degree. When I cannot go with 2 degree, I cannot go with 3 degree. Hence, this reaction is only shown by 1 degree. And which is the intermediate supporting to do the reaction? The intermediate is dichlorocarbene. This is the intermediate which is supporting. This is the intermediate supporting us to do the reaction. Clearing this part? Done? So next we are going to see the reaction with nitrous acid. Clear? So done? Okay. So make a heading. Reaction with nitrous acid. Reaction with nitrous acid. Nitrous acid beta is known as an HNO2 first of all. This is highly reactive, means it is not stable. Not stable. Highly unstable. It is highly unstable, hence freshly prepared. Hence freshly prepared. How it is freshly prepared beta? So freshly prepared is by using sodium nitrate and HCl. So you will get here NaCl plus HNO. So please remember this. Here I am starting now diazonium salts. Okay. So for making the diazonium salt, we are taking the nitrous acid, and nitrous acid is highly unstable. Nitrous acid is highly unstable. Hence it is unstable, means it is a freshly prepared. So this nitrous acid is freshly prepared. How it is prepared? Freshly prepared by taking sodium nitrate and HCl. Clear this part? Clear? So this is also used for only 1 degree amine. Okay. So you can add down here, for diazonium salt 1 degree amine is used to do. Now I am taking diazonium salt. So diazonium salt. So to prepare diazonium. So from here we can prepare diazonium salt. Diazonium salt. To prepare diazonium salt, 1 degree amine is only used. How? We will see this. See beta, we are taking RNH2 and we are reacting with NaNO2 or nitrous acid. And nitrous acid is unstable, hence it is written on the top here NaNO2 plus HCl. These two together will react to form HNO2. Why you have to prepare suddenly? Because nitrous acid is highly unstable, so on the spot, freshly prepared, you have to use this. So this will be this together will give me the freshly prepared HNO2. That's why I'm writing here. What will happen here? I'll get here diazonium salt. See here, RN2Cl. Whenever you see here N2, it is a diazonium. Diazonium, and this is one kind of a salt. That's why it is known as a diazonium salt. And what is the name? This R is alkyl. N2 we call as a diazonium. And Cl means chloride. So in this way we can prepare the diazonium salts. Okay. Now when you react with this, when you do the hydrolysis, see clearly you can see here N2 can be removed. No, clearly N2. See, this is a nitrogen gas. So here entropy is also supporting. Clearly nitrogen you can remove. Chlorine is the best leaving group, so chlorine can be easily removed. Nitrogen is a gas supported by entropy, it can be easily removed, and R also can be easily removed. So when I do the hydrolysis of alkyl diazonium chloride, so what will happen, you know? See, this nitrogen gas will be liberated easily. Hydrogen H plus and Cl minus. Cl is the best leaving group, so can be removed easily as HCl, and here R will form ROS, which is called as a alcohol. So when you do the hydrolysis of diazonium chloride or diazonium salts, usually you will get alcohol with the liberation of nitrogen gas. Clear this part? Please write down this. Now we are going to see the mechanism, and certain 2-3 examples we will see first. Otherwise you will face difficulty for the diazonium salts. Mechanism is bit tougher for this. See, I will write down here CH3 NH2, and directly in the exam if it is written like this NaNO2 plus HCl, then please remember that this is the reaction with nitrous acid, that is we are preparing here diazonium salts. So which diazonium salts will be formed? See, as it is forming here RN2Cl, so it will form here CH3N2Cl. What is the name of this? Methyl diazonium chloride. When you do the hydrolysis, so what will generate? So when the so alkyl diazonium chloride hydrolysis gives the alcohol. So which alcohol will give? Yes, CH3. So I will get here CH3OH. Nitrogen is supported, means I will liberate here nitrogen gas, and HCl will be generated here. Write down this. Clear? Now we will see this mechanism. This mechanism is bit tough. So take a screenshot. I will go for the mechanisms. Clear? Chalo. Instead of CH3, I can go with phenyl ring also. C6H5 NH2. Do at your home. Finally, you will get here what? C6H5OH, which is known as a what? Benzyl alcohol. Yes or no? Write on this. In the here you will get what? C6H5 benzyl diazonium chloride. You can do at your home here and give me the answer. Okay? Do here. So now let's see with the mechanism. See, in the mechanism first the nitrous acid will come. Nitrous acid formula is what? Beta HNO2. So N double bond O OH. Here one bond will come. Here two lone pair. If you show here, don't show, it's okay. Now see, in the first step, H plus acid will be provided from HCl, because HCl and NaNO2 is there, no? So this oxygen will donate its lone pair to this H plus, and what will form here? O double bond N, O here H, and here plus charge, here double bond. So you know that oxygen is a electronegative element. On this plus charge doesn't look good. So here see, simply water can be released. So here water will be released. It will attract all the electron from this nitrogen. So nitrogen will give its electron. So O double bond N plus, because nitrogen has given its electron. Or I can write down here NO plus, so which is known as a nitrosonium ion. Nitrosonium ion, which we call as a nitrosonium ion. Clear this part, beta? Now this nitrosonium ion is the intermediate reaction which will further reaction will occur. N is having plus charge. Now N is having the plus charge, means it can act as an electrophile, and we have a nucleophile RNH2. It is having the lone pair here. So N double bond O here plus. So this nitrogen, its lone pair will be donated to this nitrogen. So see this R N, here H, here H. Now this nitrogen, its lone pair is donated to this nitrogen, so it will create here minus charge, sorry, plus charge. because this nitrogen has donated its lone pair to this nitrogen. So here this nitrogen, double bond O. Clear? No sign will come here because that triple bond is over. 3 bonds which was required, he has got over now. Now this N plus wants to satisfy this charge. So first it will try to attract the electron from this hydrogen. So it will form what beta? Here H plus will be formed. Here R, here N, double bond O, here H. Now what will happen, you know? So now see here, now proton transfer will take place. We call as a tautomerism here now. So we call as a proton transfer, or we call as a tautomerism, H plus transfer. So this step you should remember. See beta, H will shift its bond here. So nitrogen is making a new bond with this nitrogen. So he has to break the old bond. So O bond, this pi bond will get break. So when bond breaks, electron will come out, it will create O minus. So it is O minus and there is a H plus. So here formation will occur like this, N double bond N, O minus H plus, this formation will get occur. Clear? This we call as a tautomerism also, tautomerism or tautomerized. Clear? This H should be removed. So what will happen, you know, here there is just transfer will takes place. How transfer? This H bond will cleave here, will shift here. So to this nitrogen is making a new bond with this nitrogen. So to make a new bond, old bond should be broken. So this bond will get break and enter into this oxygen. Oxygen will create negative charge. H is removed as H plus and O is minus. So OH will be formed. We call as a H plus transfer. Now see, there is a lone pair here also on this oxygen. Previously what H plus we have removed, no, that H plus will come back. This H plus will come back. It will attack on this oxygen because it is in need of electron and he is having 0 electron. So what will happen? Because easily water can be removed. So see here R, N, double bond N, here O, here H. This H plus will react with this oxygen plus charge and lone pair. Again this can be removed as water easily. So R, N, it will try to attract the electron from this nitrogen. So R, N, double bond N, here minus, and sorry, he has given the electron to satisfy. One who has given the electron creates positive charge. So nitrogen has given the electron to this oxygen, no? So nitrogen will create the positive charge and here water will be removed. N is plus. Now let us see, somewhere in the reaction there is a Cl minus also. Because we have used HCl, NaNO2 we have used, no beta? NaNO2 you have used plus HCl. So you got what? NaCl plus HNO2. So this story is remaining, no, still. So now what will happen, you know, here Cl minus will come. When Cl minus will come here, you get here R, N, double bond N plus and Cl minus, or you can write down here R, N2 Cl. So this is nothing but your alkyl diazonium chloride. This is the mechanism. Write down. Or in the further also we can see. What further? See. Further also I can show in the books. This is also correct. Another also I can show. See here. See, we got this species. No. So see, 1, 2, 3, 4, 5, 6. There is one lone pair here also. So 1, 2, 3, 4, 5, 6, 7, 8. Now what will happen? You know, this is one species. If this nitrogen donate its lone pair here, so what will happen? Because see, this is in a need of electron and it is having the extra electron. So this nitrogen, one of its lone pair will donate to this nitrogen. So what will happen? This nitrogen has given the electron, so it will create positive charge. Here triple bond N. So this bond will get satisfied. Are you understanding or not? This bond will get satisfied. So either this species or this species. Now experimental says this species is more stable than this species. See beta, we have prepared here. Now this nitrogen is in need of electron. So this nitrogen is in need of electron, means this nitrogen is having one lone pair extra. So this lone pair will be donated here. When this lone pair is donated, he has given. So it will create positive charge and he has accepted. So triple bond is over now. Now which species should be considered? This species or this species? Experimentally this species is more stable. So we are considering this. So this plus will be combined with Cl minus, which is provided by NaCl. So in short, you can write down like this, R, N2 Cl, which is called as a diazonium chloride. In this way also you can write down. And here R can be 1 degree, 2 degree, 1 degree and C6H5. It cannot be 2 degree, 3 degree. Clear this part? So diazonium chloride is only for 1 degree. Take a screenshot. If you not understand, when you come to the school, once more I will teach you. Clear? Out of these two species, the center nitrogen getting positive charge will be more stable. Experimentally has been proved. So that's why I have shifted this here. Clear? So in Rn2 nitrogen nitrogen there is a triple bond. Please remember this is the cation, not this is the cation. This is the cation because it has been asked in the MCQ. Because this cation is more stable than this. That's why I have to generate this ion. Clear? So now next we are going to see 1 degree, 2 degree and 3 degree amine test. All the three of the amine. 1 degree or 2 degree or 3 degree amine test. And this test is done by Hinsberg test, or we can say as Hinsberg test. Hinsberg test, it's not a type of a test, I can say by using Hinsberg reagent. Okay, 1 degree, 2 degree or 3 degree amine can be tested by using Hinsberg reagent. What do you mean by Hinsberg reagent? See, this is very important. Now, please see this. Hinsberg reagent, first we'll see the name. The name is benzene, sulfonyl, chloride. This is Hinsberg reagent, benzene, sulfonyl, chloride. This is common name, this is IUPAC name. So what is the formula beta? First you draw benzene, then sulfonyl means S double bond O here double bond O, Cl, or I can add down here C6H5S double bond O, Cl. This is your benzene sulfonyl chloride or Hinsberg reagent. Reactions are very long, you have to check it out to understand. Okay. This will be given, this Hinsberg reagent will give the test for 1 degree, 2 degree, 3 degree. How? We will see this. How we will distinguish the 1 degree amine, 2 degree amine or 3 degree amine by Hinsberg reagent. Clear? Same story we are going to repeat here. See here. First, understood this? First copy out this. Then I will add down 3 of them here. First we will see the reactions. I hope you written the Hinsberg reagent. See, first I will take 1 degree amine. First we will see for the 1 degree amine. See beta, 1 degree amine is RNH2. Yes or no? R, or 1 degree amine, we will take one example. C2H5NH2, here one lone pair. Clear? And I am taking benzene sulfonyl chloride, that is C6H5S double bond O, Cl. See this sulfur. This sulfur is arranged by these 3. See, oxygen, chlorine. These 3 of them are more electronegative in nature. So this sulfur, all the electron will be pushed towards oxygen, here oxygen, chlorine. So this will be having the positive charge, means this will be in the deficiency of electron. Nitrogen is having the excess electron, so this electron will be donated to this sulfur. Clear this part? So sulfur is making a new bond with this nitrogen, so chlorine has to released. So chlorine will be released as Cl minus. So Cl minus will be released. See here, what will happen here? You will see here C2H5N, 2 hydrogen up 1, here 1. This nitrogen donated to lone pair to this sulfur. Sulfur is having double bond with oxygen, here double bond with oxygen, and here C6H5. Who has given the electron beta? Nitrogen creates positive charge, and who has accept the electron? So nothing, no? Sulfur is making 6 bonds, so it has make a 6 bond. Now nitrogen is a more electronegative element beta. So nitrogen is a more electronegative element, so it will try to attract the electron, it will start to attract the electron from hydrogen. So this hydrogen will be released as H plus. So this is a H plus and there is a Cl minus. So there will be generation of HCl here. C2H5, here N, here H, here S, double bond O, C6H5. So this one clumsy compound has been formed. Now in this clumsy compound, see this hydrogen. This is an acidic hydrogen. This is an beta acidic hydrogen. So when I react with this base, when I will react this with base, this clumsy compound, when I react with this base, so base will provide OH and this clumsy compound has a one H. No need to remember the names, okay. This clumsy compound is having one H here. So this H will release as H plus and forms here OH. So here H2O will be generated and this C2H5N, here Na, here S, double bond O, C6H5. So see, this will be the soluble complex. This is a soluble complex. So what I mean to tell is, when I take a 1 degree amine, so I will form a one soluble complex and 2-time reaction will occur. This is the first part of the reaction. and this is the second part of the reaction. So when I take the 1 degree amine with Hinsberg reagent, two parts of reaction will take place, and at the end soluble complex will be formed. At the end soluble complex will be formed. We will see with 2 degree amine. See beta, we will see with 2 degree amine now. What will happen with 2 degree amine? Understood this? So this is the story with the first 1 degree amine. I need to reach here. So in 1 degree amine, I will reach at the final soluble complex. Now let us check out with the 2 degree amine. See with the 2 degree amine, suppose I am taking here C2H5 NH C2H5. Here one lone pair. Again I will take one benzene sulfonyl chloride. So C6H5 S double bond O Cl. This sulfur, again it's a need of an electron, so this nitrogen will give its lone pair to this sulfur. What will happen beta? See here. So this sulfur will make a new bond to release this Cl minus. So this Cl minus will be released. What will happen? C2H5 N, here H, here C2H5, and nitrogen will donate its lone pair to this sulfur. Double bond O, Cl is moves as Cl minus, and C6H5. Yes or no? Now this H, see this H, yes or no, which you have seen, no? Now this Cl minus will react with this H. So this in the second step, so this is the first reaction which is occur. So this H, now this is nitrogen which has donated the electron, no, plus charge. So this nitrogen, to satisfy the plus charge, will start to attract the electron from this H, will be removed as H plus, and here HCl will be generated. What is the final product? See here, C2H5 N S double bond O C6H5 C2H5. 1 2 here, one lone pair. See this, up to here I have reached. No? Now here there is a one presence of acidic hydrogen, then only 1 degree amine would have. In 1 degree amine, after doing this reaction, there is a presence of one acidic hydrogen, then only this complex compound has reacted with NOH to go further. See here, there is no acidic hydrogen. So here, if I do the reaction with NOH, so no reaction with this NOH. Why no reaction with NOH? Because there is no acidic hydrogen in this complex. Whereas in the 1 degree amine, there is a acidic hydrogen in this complex. So only the reaction is occur further with this NOH. Here there is no acidic hydrogen, so reaction cannot occur further. So what will happen? Here this is soluble complex, whereas this is insoluble complex. So 1 degree amine will produce a soluble complex, whereas 2 degree amine cannot reach to the soluble complex. The reason is what? To reach the soluble complex, there should be acidic hydrogen with the nitrogen to react with NOH, which is there with the 1 degree amine. But there is not there acidic hydrogen with 2 degree amine. So for the soluble complex, it cannot form. So it will get settled down at the bottom. It is insoluble complex. So when you react 1 degree amine with Hinsberg reagent, it will form a soluble complex. But whereas when you react 2 degree amine with Hinsberg reagent, it will not form soluble complex, it will form insoluble complex, which will settle down at the bottom. So here you can distinguish 1 degree amine and 2 degree amine. When 1 degree amine is reacted with Hinsberg reagent, it will form a soluble complex, nothing is settled down at the bottom. But when you react 2 degree amine with Hinsberg reagent, there will precipitate will settle down at the bottom. You have to check it out. When the precipitate settle down at the bottom of this complex, means it's a 2 degree amine. Clear? Let's check it out with the 3 degree amine. Take a screenshot. Take it? Chalo. Let us check it out with the 3 degree amine. What will happen with the 3 degree amine? Let us check it out. See, this is 3 degree amine. 3 degree amine. So in 1 degree amine, it is forming soluble complex. 2 degree amine, it cannot form soluble complex because there is no presence of acidic hydrogen. So further with the reaction with NOH is not possible. So it will form insoluble complex, precipitate settle down at the bottom. We will see with the 3 degree amine. So this is N, this is C2H5, this is also C2H5, and this is also C2H5. Here lone pair. In the first step, who is coming now? Hinsberg reagent beta. So C6H5 as double bond O Cl. Clear? This is a Hinsberg reagent, no? This is having the need of electron, it is having the extra electron. So see, let us check it out. Here it will give its electron. So C2H5, here N, here C2H5, here C2H5. Clear now? Here S, double bond O Cl. Who has given the electron? Plus. Now to satisfy this plus, nitrogen will try to attract the electron from whom? From the C2H5, but this cannot give the electron to nitrogen. They cannot be released as C2H5 very easily, but H can form H plus very easily. When H can form H plus very easily, this nitrogen positive charge can be satisfied, but C2H5 cannot give its plus electron. C2H5 cannot give its electron to this nitrogen very easily. A large amount of energy is required to do that, which cannot be achieved. Which cannot be achieved means here further reaction will not occur. Means this only will not be formed. When this will not be formed, so what will happen? You know, this nitrogen, see this nitrogen, what is like this? No, C2H5, C2H5, C2H5. Okay, S double bond O, S double bond O, Cl. It was saying the plus charge. See, nitrogen needs, this nitrogen is in need of electron, so this nitrogen will try to attract the electron from this C2H5, but I told you H can form easily H plus, nitrogen will get satisfied, but C2H5 cannot form C2H5 plus, it cannot form. So what will happen? Nitrogen first will ask nitrogen to satisfy its plus charge. First it will ask to this C2H5, this will tell no, I will not give, because requires large energy which cannot be achieved. Similarly to C2H5, this also, this also. So this nitrogen attract the electron from this S. When nitrogen attract the electron from this S, the reaction will get repeat. See here, if I attract the electron back from S, what I will get? I will get here N, here C2H5, here C2H5, here C2H5, and here electron, plus charge, no? So S again, this nitrogen to satisfy its plus charge, it cannot take the electron from C2H5. So this nitrogen will try to attract the electron from the sulfur. When this nitrogen try to attract the electron from the sulfur, the reaction will repeat in the backward direction. Means in short, 3 degree amine will not react with Hinsberg reagent. So in this way we can distinguish 1 degree, 2 degree, 3 degree amine. Why it cannot react? Because nitrogen forms positive charge here to satisfy. C2H5 cannot give its electron due to high energy. So this nitrogen will try to satisfy its plus charge from this sulfur. So when try to take the electron from the sulfur, here Cl will not come, here C6H5. When try to attract the electron from the sulfur, so the reaction will reverse in the backward direction, hence the reaction doesn't occur. So finally, what I can write down? Finally, the test I can write down is Hinsberg reagent test. So amine, Hinsberg reagent test and result. Hinsberg reagent test. Yes or no? See, 1 degree amine, Hinsberg reagent test will be given and result is soluble complex. Ready? 2 degree amine, Hinsberg reagent test will be given and insoluble complex will be formed. Yes or no? First, understanding? First time it will form soluble complex, that's why it will come NOH reaction will occur. In second step, what happens? Second degree amine, there is no acidic hydrogen, so it will not react with NOH. When it will not react NOH, insoluble complex will be formed. 3 degree amine, Hinsberg reagent will not be formed, so result will not be formed. So in this way, you can distinguish 1 degree, 2 degree and 3 degree amine. Take a screenshot. Thank you. In the next class, I will go with the further classes.